Hi, in this video we are going to see that we have trained a Llama 3 8 billion model for generating text to 3D environments. So right now the process of response generation is in progress. As you can see, it is generating the new response that we are expecting to have, and this is the kind of input which we have given to this Llama model on which it has been trained. So I'll also show you the sample data set of 100 rows that we have created. So first, as you can see that there's this instruction telling the model like what is expected out of it to create a 3D rack cluster system. And also we have provided the dimensions of different boxes, pallet, rack frame, so that it can build the 3D environment which is required. And in the response, we are expecting to give the transforms, the XYZ coordinate of each and every object, so that it can build a 3D environment out of it. As you can see, the generation process is still going on. So let's go through the notebook quickly to understand. So we are going to use Unsloth library because using this, like, we can train any model with less GPU requirement. So first we are going to like install all the dependencies. We are going to import all the libraries. We have done some 1V configuration, such as telling it the notebook name and also the project name to track the runs later. We have provided output directory, we have provided the sequence length. So sequence length is very important here. It tells like how much maximum it can go up to, like when it is generating the new data. And then we are like setting up the model. In this case it is Unsloth Llama 3 8 billion 4-bit model that we are going to use, and since it is 4-bit, it requires less RAM, GPU RAM, to get it trained. And then again we are setting up the PEF model. PEF stands for parameter efficient fine tuning. So this is like another kind of process which is generally used to train large language models. And also we can see like we have set up the LoRa configurations here. So this is a prompt template. So this is like the prompt which is going to be provided to train the model. Below is an instruction. Here we are going to provide the full instruction, which would be like generate a 3D environment and all that. And the response section is the actual output. So when like we are training the model, we are going to provide that response. And also I'll show you like how our input and output looks like. So I've generated like 100 files for that. So we can see like this is the input which goes
It's 12 o'clock.
for the model, generate like 3D rack cluster and all that, and also the dimensions of each and every asset. So that's the input. And now if we talk about the output, so in output we are expecting the transforms of each and every object that is going to be placed in the environment, the XYZ coordinates. So that is that. So for the first object, which is a rack frame, these are all the transforms, and such that like we can also find transforms of different objects. For example, the box 5, so it is like list of list. So list is like telling all the transforms for that particular object. So that is the kind of response that we are expecting. Then it is just like formatting the prompt and using the dataset to like behave in that proper prompt format that we have provided. Then comes the trainer part, where we have defined the output directory and different parameters, the batch size and the maximum steps learning rate. Once that is done, we are just printing out the GPU usage. So current usage like before training is this much, like around 6 gigs of RAM. So we are using NVIDIA A100 system for training our model. And this is the process, like where this is a line where the training process actually starts. So you can see it took around 18 minutes for 60 steps and 5 epochs. And we can also see the train loss going down, up and down, but mostly down as we go forward. And also we can see all the information: number of GPUs, number of samples is 100, epochs 5, number of steps, and different other information, and also like how many number of parameters are actually going to be trained. In this case it is going to be 41 million parameters which are trained. After that, we have again printed out the GPU information to see all the things, such as how much time it took to train, the peak GPU memory it utilized. And then we are going to inference our model. We have provided a sample input text to the model, and now we are going to infer it. So to infer it, like we are using text streamer, which is provided by transformer library. And also we have defined how many maximum sequence length it is going to have. So based on it, like it would generate the new tokens. So as we can see, the response is still generating. It took like a lot of time. And Okay, so now we see like when it was like generating the output, it has exceeded the maximum length that we have specified. So to like get the actual output, like the complete output, so as we can see, let me check. So it has generated the coordinates for rack frame, and it was in the process of generating everything, and we see like there is box 2, and there are like couple of other objects that it requires to send the transforms of, but because of the limited context length it stopped in between. So that's like a problem for us. So we have to actually increase the context length to fit the complete model uh, output, so that it can be actually used by our system to generate 3D environment. After that, we are just going to like save the model in one of the output directories as passive as specified here. So in this case, it is racks v3 folder, so that we can again load up and use it later. And yeah, so yeah, so was the process that we are currently using to train our LLM model to generate 3D environments from text, so that in future it becomes easy for anyone. So our long term vision is to like make it generalized. Right now it is only working for the racks use case, racks cluster use case, but yeah, we want to generalize it for any indoor 3D environment development. So yeah, stay tuned.